day everyone. So I'm going to discuss about the given topic. So I am Engine Cadet Abelanosa Jailord, and we have the learning outcomes. At the end of the session, the student shall be able to identify engine performances essential for monitoring and recording during operations of marine diesel engines such as engine load, exhaust system, cooling water system temperatures, and engine performance tests. So first, let's talk about the engine load system. So what is engine load? The engine load basically determines the capacity of the engine to produce power. It is the force which resists the power produced by the engine. Every engine is designed for a particular load called as rated load or maximum load at particular speed. Whenever the load on an engine increases, the engine speed decreases. So meaning to say, engine load basically determines the capacity of the engine to produce power whenever the load on engine increases or the engine speed decreases. So that's an engine load system. So the engine load is the power of the engine, in example the torque output of the engine, and it affects the combustion parameters of an engine. An electronic control engine has many combustion parameters such as air fuel ratio, exhaust temperature, and torque, which affect the efficiency of the engine based on the engine load conditions. The parameters on an internal combustion engine need to be optimized to increase the efficiency of the engine. Improvement in efficiency yields significant benefits in fuel consumption and lessens exhaust emissions. Knowing engine load information during operation helps to adjust the parameters, since optimum parameters depend on the engine load. So that's the engine load system. So next topic is about the exhaust system. So the modern exhaust gas system of marine engine is designed in such a way that the unused gases coming out of the cylinders are further directed to turbocharger, an exhaust gas boiler, to recover most of the waste energy from the same. So these are the components or the example illustration of exhaust system. We can see the silencer type, emergency engine, expansion joint, pipe anchor, exhaust manifold, turbo, auxiliary engine, main engine, and incinerator. So first, we have the components for the exhaust gas system of engine. To utilize the maximum energy from the waste gases, the exhaust gas system of marine engine is provided with the following components. So these are the components: exhaust gas pipes, exhaust gas boiler, silencer, spark arrestor, and expansion joints. So let's talk about first the exhaust gas piping system for marine engine. The exhaust gas piping system conveys the gas from the outlet of the turbochargers at the atmosphere. For designing the exhaust piping system, following important parameter must be observed: the exhaust gas flow rate, maximum back force from exhaust piping on turbochargers, exhaust gas temperature at turbocharger outlet, maximum pressure drop within the exhaust gas system, maximum noise level at gas outlet to atmosphere, sufficient axial and lateral elongation ability of expansion joints, utilization of the heat energy of the exhaust gas. The exhaust gas from the cylinder unit is sent to exhaust gas receiver, where the fluctuating pressure generated from the different cylinders are equalized. From here, the gases which are at constant pressure are sent to turbocharger, where waste heat is recovered to provide additional scavenged air to engine. So next, exhaust gas boiler is considered to be the one of the most efficient waste heat recovery system designed for a ship. When the ship propulsion plant is running at its rated load, the auxiliary boiler can be switched up, as the engine gas boiler can generate the required steam for various ship system. The exhaust gas passes on exhaust gas boiler, which is usually placed near the engine top or in the funnel. So next component is silencer. So the exhaust gas piping system are generally close to accommodation, hence the reduction of noise from them is important. To get noise level, it is recorded at a distance of 1 meter from the exhaust gas pipe outlet edge at an angle of 30 degrees provided the exhaust gas system of the engine are without engine gas boiler or silencer. Silencer is used to reduce the noise in the exhaust gas manifold, and they are generally placed after the EGB. The conventional silencer consists of absorptive and reactive chambers. They are constructed for a gas velocity of 35 meters per second, and the reactive chamber is only effective at one frequency. And the next component is spark arrestor. The load operation of marine engine tends to produce partially burned carbon deposits and soot with the exhaust gas piping system of engine. As the exhaust gases produced after combustion are rich with oxygen, these partially burned carbon particles are discharged from the exhaust funnel as highly dangerous spark. So, spark arrestor can be fitted in the exhaust piping system to prevent sparks from the exhaust gas being spread over the direct house. It is placed at the end of the exhaust gas system of the engine. So the main disadvantage of spark arrestor is considerable pressure drop. For main engine of a ship, it is recommended that the combined pressure loss across the silencer and or spark arrestor should not be allowed to exceed 100 mm WC at specified MCR. So the next component of the exhaust system is expansion joints. So the exhaust gas system of an engine experiences huge temperature variation. It is not impossible to construct the entire exhaust piping system in one single piece, hence multiple sections are joined to complete the system. This major temperature variation requires need of joints to safely absorb the heat-induced expansion and contractions of pipes and tubing systems. For this purpose, bellows and expansion joints are used. They are designed accurately to make sure that they are able to withstand the stresses and avoid cracks brought about by the continuous change in the temperature of the system. Expansion joints are used in tubing and piping system, and bellows are generally used to connect exhaust gas pipes to the funnel. The expansion joints are to be chosen with an elasticity, the limits, the forces, and the moments of the exhaust gas outlet flange of the turbocharger as stated for liters.
The machinery systems fitted on board ships are designed to work with maximum efficiency and run for long hours. The most common and maximum energy loss from machinery is in the form of heat energy. This loss of heat energy has to be reduced or carried away by a cooling media, such as a central cooling water system. To avoid malfunctioning or breakdown of the machinery, there are two cooling systems used on board for the cooling purpose. First is the seawater cooling system. Seawater is directly used in the machinery systems as a cooling media for heat exchangers. Freshwater, second is a freshwater or cooling central cooling system. Freshwater is used in a closed circuit to cool down the engine from machinery. The freshwater returning from the heat exchanger after cooling the machinery is further cooled by seawater in a seawater cooler. Understanding the central cooling system, as discussed above, in the central cooling system, all the working machinery on ships are cooled down using circulating fresh water. This system comprises three different circuits. First is seawater circuit. The seawater circuit is used as a cooling media in large seawater cooled heat exchangers to cool the fresh water of the closed circuit. They are the central coolers of the system and are normally installed in other places. Low temperature circuit. The low temperature circuit is used for low temperature zone machinery, and this circuit is directly connected to the main seawater central cooler. Hence, its temperature is lower than that of high temperature HT circuit. The LT circuit comprises all auxiliary systems. High temperature circuit, the HT circuit in the central cooling system mainly comprises of the jacket water system of the main engine, where the temperature is quite high. The HT water temperature is maintained by low temperature fresh water, and the system normally comprises of the jacket water system of the main engine, freshwater generator, DG during standby condition, low oil filter for stopping box drain tank. The The HT cooling water system is circulated by electrical cooling water pumps, one in service and one on standby. During standby, the DJ is kept warm by the circulating system from the DJ in service. Temperature control valves. The heat absorbed by the HT circuit is transferred to LT circuit at the temperature control valve junction. The outlet temperature of the main engine cooling water is kept constant at 85 to 95 by means of temperature control valves by mixing water from the two central cooling systems, in example, low temperature system into the high temperature system. That's all, thank you. And now, I will show you a video of how engine performance testing is done in the onboard ship.
So sa araw na yun ito, ang topic natin ay kung paano kumuha ng main engine performance, no? Manual. No? So, punta tayo doon sa harap ng engine para kumuha ng main engine performance. This is Chief Engineer lang, no? This is my lab. Kuha tayo ng manual performance ng engine, no? Plain lang siya. Tapos, bukod natin na ngayon. Siguraduhin mo, mahigpit ha.